actually going to be concluding just this section. We're getting to maybe one of the best parts here, and that is we want to address the questions that have come from the audience throughout our presentation today. So we've arrived at that point, and some of you have been sending questions in already via the chat window or the questions menu, and now we will try as best we can to answer them. And it is not too late. If you still have questions while we're addressing them right now, you can continue to use the chat and the question menus to submit your questions. So let's look at some of the stuff that has come up throughout the day. One of the questions was, let's see, we did have someone who was mentioning 500 megahertz as a synchronization clock. And I'm wondering if Steve or Dominique, are we looking at the capability of being able to sync to a 500 megahertz master clock?
So Dominique, yes, we can synchronize the timing system with a clock in factory, and the frequency can be between 10 megahertz to up to 500 megahertz.
It's very good. Very good. So that's just sort of one of those things that just go ahead and ask. Call us and ask if we can do it, and give us the opportunity to provide a solution for you. Let's see. So I believe that 500 megahertz was part of a particle accelerator. I've got another attendee who was mentioning 75 megahertz titanium sapphire laser oscillator. It sounds to me like that's well within the capability of all of the products that we've discussed today.
Yes, totally. Yes.
Okay. Very good. Thank you, Steve. Go ahead.
Regarding high speed frequencies, we have made a generator with a clock higher than 1 gigahertz. That was 1.15 gigahertz. So.
Oh, wow. Okay. Very good. That's very good to know. I think everybody would like to hear that. Let's see. A master clock with serial commands. Is there an open protocol? I see. Okay, so the question is, can a non-BNC or even perhaps a non-Greenfield device be connected to the fiber and send the master clock and serial commands in the way that the 3001 does? That sounds like a tall order, but Dominique or Steve, what's your thought on that? Hello?
Yes. I don't know if it's me or Dominique who will.
Okay.
I don't know what the attendee means, but the master clock is mostly a clock, so a non-BNC device will see that as a clock. If it's a timing system equipment, so it may wait for specific message. So maybe we can adjust our message to their equipment. That's possible.
Okay. So that's something that certainly could be looked into and discussed to see what could be done to make any existing products in an application compatible. Very good. Thank you very much. Let's see, a question regarding high harmonics. Now, I'm not sure I'm getting the full understanding here, but do you have a solution in order to make high harmonics from a 80 megahertz system? So I guess perhaps what is being asked, and it's very difficult without getting clarity back from the questioner, that if 80 megahertz perhaps is the synchronization clock, the clock in, is the system or are the products able to create or generate higher harmonics of that master clock?
And so Dominique, we have designed a small module. The reference is a GFT300, and we can receive electrical or optical clock. Generally, it's a very short pulse, and we convert this very short pulse to a sine wave at 80 megahertz.
Okay, very good. So thank you very much for addressing that question. A question was asked, what is the best design practice? Say a synchronous or an asynchronous design. What's the best clock method, perhaps for synchronous or asynchronous design? Is that question making any sense in the way that I'm able to phrase it?
Oh, that really depends on the topic of the experiment. We are actually, we are specialists on synchronous systems, but we are also making asynchronous systems.
Okay.
We know that it may be important for people to have in synchronous system perfectly asynchronous, so that's difficult to make asynchronous systems. So we may need more information to answer correctly the question.
So that would require a little bit more input, application description from the customer, from the designer. All right, very good. Question, customers asking, will the slides be sent later? And yes, all of today's attendees will be receiving a copy of today's presentation, of the slide presentation. So thank you very much for asking that one. Let's see, what else have we got here? Is it possible to use a master clock for maximum stability? Okay, so a particular application is using an 80 megahertz laser oscillator, and is it possible to use it as a master clock for maximum stability, but trigger the slave only on single shots, or say something as slow as 10 hertz frequencies? It sounds to me like this is something maybe we're already doing on some of the applications I'm familiar with. Dominique or Steve, do you want to jump in on that?
Yes, that's really a typical application. That's about, it's very close to the laser application I presented, I think. Okay,
very good. And here's a very good question regarding amplitude, the outputs for the devices. Can we deliver TTL level into 50 ohms? I'm pretty sure we can do that just fine. In fact, there's probably several options for many of these products, and the options can be chosen from the ordering sheets. But can someone go ahead and please acknowledge or confirm that for me?
Yes.
TTL.
TTL are very common. Yes, it's easy.
Okay. And true TTL levels into 50 ohms. Very good.
Yes.
Yes, but we can deliver also 10 to 32 volts with a very high speed rise time.
I know that there are very many options that are available for the output. So yes, thank you very much for bringing that up. I have a question here that I'm not quite sure I know. Are we working with AWG? I assume we're talking about an arbitrary waveform generator. And I'm not sure if the question is, are we producing arbitrary waveform generators, or perhaps are we working with arbitrary waveform generators as triggering or as source, as clock synchronization sources? Do you guys have any kind of a response for that question?
It's difficult. It's necessary to have more information because we design a digital pattern generator, and we can synchronize this digital patterns generator to the timing system, or we can design optical AWG.
Okay. Thank you very much. And let's see, what else have we got here? A 1 to 10 nanosecond timing requirement. So for the 5 volt, so the 5 volt TTL signals traveling over 20 meters, can we do a high precision system? It would seem to me, that would be tough for electrical signals, but I'm wondering if that's an opportunity to use optical fiber and then convert the optical back to electrical, but perhaps I'm overstepping my knowledge of what can be achieved. So we're looking at 1 to 10 nanosecond timing requirement, the signals being 5 volt TTL over a distance of 20 meters. Is this something that can be addressed?
It's Dominique. What is the timing requirement? It's a jitter, drift, accuracy. It's difficult. It's necessary to have more information.
Okay, well, it looks like, I think, from some follow-up information here, that the application itself seems to be constricted to using 50 ohm cables and connectors. So this looks like something that would have to be conducted entirely on an electrical level. But that's something I think that would be worth following up. We certainly ask, or would invite you to contact us with your application description, and we certainly give it a good look. We also have a follow-up to a question earlier where I was asking whether the 80 megahertz could generate harmonics. So a little more specifically, would we be able to take a 80 megahertz synchronization clock and create 800 megahertz, an 800 megahertz system synchronized with that 80 megahertz clock? Do you gentlemen have any experience or that you can draw on to answer that question?
It can be a custom solution. It's possible, but it's not standard today to go that way. But it's something that we like to do for customers.
Okay, very good. And I think that is a point worth bringing up is, yes, we do an awful lot to keep our customers aware of our standard products, and we do have a wide range of standard products available, but we also have the capability and the interest, and we do give a damn, and we will do, at least consider, we will consider and discuss customizations and what are the other words I'm trying to, but customization of our systems to meet your particular requirements. So don't be afraid. Please contact us and let us know what you need. It's certainly worth discussing. And it looks like we're pretty much coming to the end of the questions. We certainly have done our best to answer the questions that have come in via the chat and the question windows. And I apologize if we weren't able to answer all of them here in the moment. Perhaps we overlooked them, but each of today's registrants will receive a complete list of today's questions and answers, along with the copy of the slides of today's presentation. So by all means, please keep watching your inbox for these and any other goodies that we will be providing to our attendees today. We thank you very much. Also keep watching your emails for when we announce our next installment of BNC's Evolution webinar series. So in closing, I want to thank Dr. Dominique Monnier-Bourdin, Product Manager at Greenfield Technology, for his participation, his help in today's webinar. Thank you very much, Dominique. Also, thanks to Junior Che, Product Manager for Test and Measurement, at BNC. I want to extend a special thanks to Dr. Steve Hockey, project manager at Greenfield Technology, for his expertise and instruction in high-performance timing systems. Thank you very much, Steve. I do appreciate it. I want to thank two more individuals, Matteo Craftso and Mia Nelson, for their invaluable work behind the scenes in making today's webinar possible. Thank you both very much. And all of you, today's attendees, thank you very much for joining today. I hope that you've all benefited from the information we presented. You all have important matters to attend every day. We know that. We want to thank you so much for having spent this portion of your time with us. Have a wonderful rest of the day. And on behalf of Berkeley Nucleonics, this is Mark Slattery saying goodbye.